Hello, welcome to the online course on problem solving using C. Let us go and discuss ahead about two-dimensional arrays. Two-dimensional array in C language is represented in the form of rows and columns, also known as matrix, which is also known as array of arrays or list of arrays. Here, understanding the matrix structures and multidimensional data organization in C programming. Two-dimensional array. What are two-dimensional arrays? They are used to represent rows and columns to form a matrix structure, also called as arrays or list of arrays. Two-dimensional arrays, three-dimensional arrays, or any dimensional arrays, also known as multi-dimensional arrays. Here, how do you declare? When you are declaring, you have a basic syntax, you have an example, you are having an alternative method. Basic syntax, data type, the type of the array, the name, and the size of the index. So when you're taking 4 by 3 matrix, it means it is creating a 4 by 3 integer matrix. Alternatively, you can create a 3 by 4 matrix. This code creates a 4 by 3 integer array, which is used for two nested for loops to visit each position. Outer loop controls the row traversal, while the inner loop controls or handles column traversals within each row. The array index starts at 0. So 4 by 3 array uses 0 to 3 and column indices 0 to 2. The condition is I less than 4 and j less than 3. How do you initialize an array? When initializing an array, we have different concepts. Row, major order, index, bound, and nested patterns. So here, when you are initializing the rows, row 0, row 1, row 2, row 3, it will be visualized. So each row is an array itself creating grids where array of I and array of j, which access the elements in row I and column j, which follows the pattern array of 0 with 0, array of 0 with 1, array of 0 with 2, array of 0 with 3, if it is 4 by 3 matrix. So the initialization, each inner set of braces represents a row in the matrix, which creates 4 by 3 array with sequential values. How do you access? An element in two-dimensional array is accessed by using the subscripts. That is nothing but row index and column index of the array. The syntax array of I and j, which retrieves the element at row I and row j. Here you are taking for loop for I is equal to 0, I less than 4, condition is 4, and I plus plus. J is equal to 0, condition is j less than 3, and j plus plus. So here, array of I and array of j, you will be printing out with the first column and the second row. Here you have matrix addition. Matrix addition, we have two input matrices where there should be identical dimensions. Element wise, you add corresponding elements from each matrix so that it results in a new matrix containing sum of elements. So here you will go with declaration, main, you're declaring the variables. You're giving printf statement where you enter the rows and columns. You're giving a scanf statement where it gives you the output. You again enter the elements of a matrix where you check with the condition of for loop, I value and j. Because it is 2D, we go with only I and j. You will give the values of I, you will give the values of j along with the condition. You give scanf statement. When you give again the elements of matrix B, you again declare it with I and j, where you find the number of matrices elements. So again, the element of matrix A and matrix B. So here are the addition of two matrices. That is, the sum C of I and j is equal to A of I, A of j plus B of I and B of j. The value you get a new matrix which contains sum of all the elements. Here, in matrix addition, you take two matrices which are identical. You add element wise, that is, you are adding corresponding elements from each matrix. Finally, you are getting a result with a new matrix containing sum of all the elements, which is nothing but AD plus BC. You follow AD plus BC rule. So that the first row and the first column, first value, and the first row of the first value of the second matrix. So both should be added, and you'll get finally a sum of all the elements in a new matrix. You have matrix multiplication. When you're going with matrix multiplication, you take similar values, you take rows, you take columns, where you go and run with a for loop. So here, as it is only two-dimensional, you go with I and j. The columns of first matrix must match the rows of the second matrix. Here what happens is, you're taking printf statement to enter the rows and columns of A matrix. You're printing it, going again with B matrix, printing it, now going with the loop to check the condition. If your condition is matched, 3 by 4 matrix or 4 by 3 matrix, you can consider any matrix. So alternatively, you go with 4 by 3 matrix. So you go and check for loop I is equal to 0 as the index starts from 0. The condition is 4, I value is 4 and j value is 3. So here you will enter the elements A and B. You will go with the product, that is nothing but dot operator, where product of rows and columns, so that you will get a proper output which is calculated after each element. And finally you get a multiplication. You have to multiply the first matrix of the first column, and it should match the second matrix of the rows. Multi-dimensional array. Multi-dimensional array is also called as 2D or more than 3D or more than 2D. So how do you initialize? You can initialize the same way the 2D dimensional has been initialized. But here, as we are telling it as 3D array, so 3-dimensional. Along with rows and columns from 2D, 3D is nothing but it adds on with depth. So depth, rows and columns. So let me consider A of 2, 3 and 4. So you can give different values. You can initialize using a nested braces for each dimension. How do you access? As we already know, 2D is nothing but array of I and j. But when coming to 3D, array of I, j and k. Here you can take an example, or you can store 12 values because it is 3 by 4 and you will enter 12 values. As we already know, the access will be with the help of I, j and k. So here when I'm running in the loop for loop with I, with j and k, so that it will return me 12 values, out of which it will display array of 0, 0, 0, array of 0, 1, 1, array of 0, 1 and 0. So here what is happening is the first column, first matrix, first column, first value should match the second matrix, second row values, second matrix values. So that every time you get array of 0 with 0, 0, 1, and array of 0 with 1 and 0 and 1. Again array of 0 with 2 because it is 4 by 3 matrix, array of 0, 1, 2 and 3. So finally you will get 12 values. The code 4 by 3, it uses two nested loops to visit each position. The outer loop I, which controls the row traversals, while the inner loop J handles column traversals with each row. This pattern visits elements in row major, which orders from left to right across each row, top to bottom through all the rows. The array index starts at 0, so a 4 by 3 uses row indexes 0 to 3 and column indices 0 to 2. Here we follow a condition I less than I less than 4 and j less than 3, which ensures we stay within the valid bounds. When we are visualizing the array structure, it will be shown as row of 0, 1, row 1, row 2, row 3, row 4. Each row is an array itself, creating a grid where array of I, j and k, which helps in accessing the elements at row I, column j. The traversal order follows a pattern array of 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 1, so on. When we were going with the nested loop, the outer loop I is equal to 0 begin at the first row. Inner loop j is equal to 0, 1, 2, which process all the columns in row 0. Next row I is equal to 1, which moves to the second row. The repeat pattern which continues until I is equal to 4. That is nothing but the condition I is equal to 4 where it exits a condition. The output shows each array element printed with its position. Each line displays the current row index I and the column j where the values are stored. The systematical traversal ensures no element is skipped when we were demonstrating or predicted any order of nested loops in execution. So here you can see an example of 3D array, which creates 3D array for storing 24 elements across 2 layers so that it contains a 3 by 4 matrix. In real world, 2D is essential, but 3D is more for game developments or scientific computing or database operations. So when we were doing many approaches for storing data, here in 2D you can store only 12 elements, whereas in 3D you can store for 24 elements because we are taking 2 layers so that each layer contains 3 by 4 matrix. So each one 3 by 4 matrix gets the output of 12 values. The other 3 by 4 matrix get the values of 12 by 12 values. So overall 24 elements will be stored in 3D array. The row major order elements are accessed from left to right, top to bottom, which matches how arrays are stored in memory. Here index bounds. What is again index bound? Use always rather than the less than while checking less than symbol or less than or equal to, because the condition is used to avoid out of bound errors. When coming to the nested pattern, the outer loop controls rows, inner loop controls columns. This pattern works for any 2D array. Common variations we see in column major traversal. Row major traversal, as we already spoken. Column major traversal, we can swap the loop order to process all the rows in column 0 and all the rows in column 1. When coming to the condition, when the conditional processing is done, adding if two statements inside the inner loop to process only specific elements. You modify during the traversal. You can even update or modify array of I and j values during the loop to transform the entire array. Here in matrix structure, you organize data in rows and columns for efficient access and manipulation. Index access. You use rows and columns to indices to access specific elements in the array. When the operations are performed in two-dimensional, we get additional and multiplication on matrices with matching dimensions. As we already spoke that the columns of first matrix should match the rows of the second matrix. AD plus BC, AD minus BC. So that you get AD minus BC, you get direct addition. AD plus BC, that is the first row and the first column of the first matrix and the second the matrix first row should be matched with the dot operator, that is a product operator. Finally, you extend the 3D and higher dimensional for complex data organization needs. In real-world entities, 2D traversal is essential for image processing, like pixel grids, game development, like tile mappings, scientific computing, like matrices, and any other database operations, like tables, rows, and columns. The nested loop pattern demonstrates here forms the foundations for more complex algorithms, including matrix multiplication, flood fill operations, and pathfinding in grid-based environments. While Conio.h and ClearScreen are non-standard, the array traversal logic remains valid in modern C. Use standard inputs like printf and scanf for portable code. Exporter.